What we're doing is we're setting up a pretty large array of buckets. Around 400 buckets. And we've set into the pivot panel a pattern of water that we want to apply over these buckets. And then we'll apply that water. This pivot here is outfitted with a VRI system, where each of these nozzles is controlled by a valve. There's a GPS location inside the pivot panel that tells the nozzles when to turn on. You can think of it like a giant dot matrix printer for water. You send the pivot a picture of the water depth that you want it to apply, and that water depth is applied across the field. The question is, how accurate can we get? When we talk about precise or precision agriculture, how precise can we be? And that's the question we're trying to answer today. Buckets are set up so there's 4 within each management zone of the pivot. They're about 20 feet apart in this frame, and they're 20 feet apart in the radial direction along a line, like we are here. The way it looks in the arcs is variable. It's about 20 feet at the far end, and it gets thinner as we go in. So how do we know exactly where our buckets are? We're using a real-time kinetic GPS unit here. Jason's on operating. And what this does is it gets us the position of the bucket within about a centimeter. Then Colleen comes in, puts the bucket in place, and Gabby does the hard job of planting the bucket. Here we have our trial set up, water's going, and some of these are going to be cycling on and off. You can see we've only turned on the pivot to water where it's going to see the buckets here coming up, just so we save water for the grower. And we've got manpower here today that after the pivot goes over these buckets, we'll take up each and every single bucket and we'll weigh it. Each bucket is numbered so we know exactly where every bucket is. So we know then exactly how much water was put in every place here on this field. What we hope to do is give advice to the growers so that they can leverage their capital investment in the most appropriate way, so that they don't over-design their systems or under-design their systems in response to the variability that's apparent in the fields. The project is funded by the Northwest Energy Efficiency Alliance, who works out of Portland, and they take money from power utilities and invest it in creating more efficient technologies. This could be anything from light bulbs and refrigerators, but it's also irrigated agriculture. In Oregon, irrigation represents about 5% of the total power load of all the electric that we use. And NEWAG is trying to make, and is charged with making, an impact in terms of increasing the efficiency of irrigated agriculture. Within the Department of BEE, my lab focuses on the nexus of energy, water, and agriculture, or NEWAG for short. We think about the processes that link water use, energy use, and food production. Because these things, if you can think about it, takes water to make food. Water can be used to make energy. We all need water in our daily lives. You can take the products from agriculture and turn them into energy. So these resources are fungible. These resources are linked. And to sustainably manage all 3 resources, we have to think about it as a system and how to make wise choices in our management practices. The idea that we can put the right amount of water in just the right place at just the right time, where the plants need it in a field, could fundamentally change the way we perform agriculture.